Welcome to this comprehensive tutorial on loading 3D models from files into Java applications. In today's video, we will explore everything from setting up your environment to displaying 3D models using Java libraries. Make sure to follow along as we cover essential concepts. Let's start with an introduction to 3D models. A 3D model is a mathematical representation of a three-dimensional object, commonly used in video games and simulations. These models can be saved in various file formats such as OBJ, STL, and FBX. Today, we will focus on the OBJ format, which is widely used and supported. First, let's set up our project environment. We will be using Java with the lightweight Java game library, LWJGL. LWJGL provides a lot of functionality for graphics rendering, including support for OpenGL, which is perfect for loading and displaying 3D models. To create our project, we'll use Maven. If you haven't used Maven before, it's a build automation tool used primarily for Java projects. Create a new Maven project in your favorite IDE. Next, let's add the necessary dependencies to our pom.xml. We need LWJGL and a library for loading OBJ files. Here's how to add those to your project. After saving the pom.xml, make sure to refresh your Maven project so that the dependencies are downloaded. Now we're ready to set up our main application class. Now that we have our basic application structure, let's configure OpenGL. OpenGL is the graphics API we will use to render our 3D models. Start by setting the viewport and clearing the screen in the render loop. Before we dive into loading 3D models, let's discuss the OBJ file format. An OBJ file consists of vertices, texture coordinates, vertex normals, and faces. It's a plain text format, which makes it easy to read and modify. To load a 3D model from an OBJ file, we will utilize the ASIMP library, which is an open-source library for importing various 3D model formats. The first step is to create a method that loads the OBJ file. In the load model method, we use asimp.ai import file to load the model from the specified file path. If the loading fails, we print the error message. The next step is to process the scene data to create a usable representation of the model. The vertex data can now be stored in a custom vertex class. Let's create that class to encapsulate the properties of a vertex. Next, we'll need to extract the indices for the faces of the model. Indices are used to specify how vertices are connected to form faces, which are essential for rendering the model correctly. Now that we have both vertices and indices, we can create a custom model class to encapsulate the data structures required for rendering the loaded model. The model class will be responsible for storing vertices and indices, as well as handling any rendering logic. Next, we need to add the code to upload the vertex data to the GPU using OpenGL. OpenGL requires us to create a vertex array object, VAO, and a vertex buffer object, VBO, to handle the rendering. In the code above, we generate a VAO and bind it, then create a VBO for the vertex data. Now we have specified how the vertex data will be interpreted in Vulkan using the glVertex attrib pointer function. This connects the vertex buffer data with the vertex shader attributes. Let's go ahead and create a simple vertex and fragment shader to apply to our model. In the shaders above, the vertex shader simply passes the vertex position to the fragment shader, which outputs a constant color. In a real application, you would add more complex functionalities such as lighting and textures. After creating the shaders, we must link them to create a shader program. This program will be used during rendering to apply transformations and colors to our object. Now that we have set up our shader program, let's add the code to render our loaded model in the main render loop. This is where we actually draw our 3D model on the screen. Great! We now have a complete rendering setup. As a quick recap, we have covered how to set up Maven, load OBJ files using ASIMP, create a vertex buffer, and write basic vertex and fragment shaders. To wrap things up, let's run our application and see if we can load a 3D model from a file and display it on the screen. If all goes well, you should see your loaded model rendered beautifully. This concludes our in-depth guide on loading 3D models in Java. We covered a lot of material today, from project setup to rendering the model. I hope you feel empowered to integrate 3D models into your own projects. If you enjoyed this tutorial and found it helpful, please consider liking the video and subscribing to my channel. Don't forget to check out the description for additional resources and links to the code we discussed today. Happy coding!